Okay, so what we're going to do today is multiply some fractions together. So the important points here to understand that multiplying fractions is easier if you first cancel common factors from numerators and denominators in each fraction. To know that a whole number can be written as a fraction with a denominator of 1 is a very important thing. So any whole number can be rewritten as 13 over 1. To be able to multiply fractions, mixed numbers and or whole numbers, giving the answer in its simplest form. So without further ado, let's get stuck into it. So here is the first scenario. So what does it mean to multiply a fraction? And in this case, what we're doing is we're multiplying by a whole number. So 4 times 3/5. This means 4 lots of 3/5. And I don't know about you, but in primary school, I was taught 4 and multiply was taught as groups of 3/5. What we used to do was like make 4 groups. So here's group 1, 2, 3, and 4. And in each group, we have, in this case, 4 groups of 3/5. So that's 3/5 plus 3/5 plus 3/5 plus 3/5, which we recall from addition is we've got 3 parts out of 5 plus 3 parts out of 5 plus 3 parts out of 5 plus 3 parts out of 5, which is equal to 12 parts out of, not 15 as I was writing there, but 12 parts out of 5. All right, so the way we're going to note on this one here is I'm going to write 4 over 1 multiplied by 3 over 5. Now notice here what we're doing when we multiply by 4 is we're multiplying the number of parts, okay, that we have by 4. So 4 lots of 3 is 12, but what the parts are divided into, or how many parts that there is, that stays as 1 times 5, which is 5. So 4 groups of 3/5, or 4 times 3/5 is 12/5. All right, this one here, what we're going to do is we've got half times a quarter. So this essentially is the same as half of a quarter. So this diagram here represents a quarter. All right, now what would be half of the quarter? Well, let's have a look at what that would be. So half of a quarter is going to be an eighth, right? So 1/8 and 1/8. Right, so 1/8 plus 1/8 is 2/8. 2/8 is the same as 1/4. So a half of a quarter will be equal to an eighth. Now, how can we do that mathematically? Well, notice here what we're going to do is multiply the numerators together, 1 times 1, and multiply the denominators together, which is 2 times 4, which is equal to an eighth. Okay, this one here we've got 2/3 of 3/5. So we want 2/3 of 3/5. Okay, so this is 1/5. Oh, that's not going to be very well spaced out. 1/5, 2/5, 3/5, 4/5, and 5/5. And what we've got is, this is 1/5 here, 1/5 there, and 1/5 there. So that's 3/5, and we want 2/3 of all of this. All right, so how are we going to do this with a diagram? I'm just going to draw a similar diagram up the top there. Okay, and what we want is 2/3 of it. So I'm going to take this 1/5 and split it into 3 parts. Okay, that's going to be a 15th, 15th, and a 15th. And I want 2/3 of them, 2/3 of the 3/5. So I'm going to take 2/3 of that, plus another 15th and 15th, and I want 2/3 of them, and 15th 15th, and a 15th, of which I want 2/3 of them. So in total, did you notice there that I wanted a 15th, a 15th, a 15th, a 15th, a 15th? How many 15ths was that? That was 6 15ths, or in this case, if I divide by 3 and divide by 3, 2 on 5. Okay, how would we do that mathematically? Well, notice here that we get 2 times 3, which is 6, 3 times a 5, which is 15, and if I divide by 3 and divide by 3, the answer is 2 on 5. So there's the same answer. Which one do you think is easier? I certainly think doing it this way rather than using a diagram is easier, but it's important to be able to draw a diagram so that you understand what's going on. So here's some further examples. So for this one here, what we're going to do with this one here is simply see if we can find or simplify these fractions. 7/10 and 1/6 can't be simplified. So we're going to go ahead and multiply. 7 times 1 equals 7, 10 times 6 is equal to 60, and the answer is 7 on 60. So 7/10 of 1/6, 1/6 is 7 on 60. Right, this one here, what we're going to do is see if we can simplify the fractions. Now, have a look at this. 11 on 16 can't be simplified, and 2 on 33 can't be simplified. Okay, so I'm going to show you 2 ways of doing this problem. I'm going to now go ahead and multiply. So I've got 22 over 16 times 33. That's a really big number. 8, 1, 3 is a 3, 4, 6 3s are 18, 1, 1 3 is a 3, plus 1 is 4. 8, 2, 1, 5. 528. All right, now notice that they're both even, so we can get 2 into it. So that's divide by 2, and that's 11 over. 2 goes into 5 2 times, remainder 1, 12, 6, 4, 264. Now, believe it or not, I know that 11 is going to go into 264, okay? So I'm going to divide by 11 and divide by 11. 11 goes into 11 once. How many times am I going to get 11 into 264? Well, let's see. 11 goes into 2 0 times. 11 goes into 26 2 times, remainder 4. 11 goes into 44 4 times. So the answer is 1/24. And notice how hard the mathematics was on that. I mean, not particularly difficult, but I bet you didn't know. If I said 264, will 11 go into it? I bet your gut says it will not. How do we prevent some of this taking place? Well, there's an easier way to do this problem. All right, so notice how we tried to simplify the fractions by looking up and down. The other way we can do it is by looking crossways, okay? And actually have a look at and see if we can simplify these numbers before we multiply rather than doing it after we multiply. That's a much easier way to do it. Do it before rather than after. All right, so notice here that we've got 2 and 16. And what I do is I think, what will go into 2 that will also go into 16? Well, it's 2. 2 will go into itself once, 2 will go into 16 8 times. Now, 11 and 33, what will go into 11 that will also go into 33? Well, the answer is 11. 11 goes into itself once, and 11 goes into 33 3 times. Now what we can do is go ahead and multiply the remnants of that. Okay, so 1 times 1, that's a difficult problem, that's 1, and 8 times 3, which is 24. Now notice I've yielded exactly the same result without any need for doing any of these big calculations here. All right, none of those were required at this point because what I did was caught out the simplifiers beforehand rather than after. Now notice here how I divided by 2 and then divided by 11. Have a look at what I've divided by in the problem before multiplying. I've divided by 2 to get these numbers simplified, and I've divided by 11 to get these numbers simplified. So you can do it after, but look how hard it is. If you get it beforehand, it's so much easier to do this problem. Following a class party, Sarah has 8/11ths left of her birthday cake. Sarah would like to take a quarter of the remaining cake home to share with her family. How much will she take home? Well, she's going to take a quarter of 8/11ths. And that's a quarter times 8 on 11. All right, so just like last time, what we're going to do is see if we can simplify the fractions. So we're going to look up and down, and those fractions are fully simplified. Now we're going to look crossways and see if there's anything we can do across those. 1 and 11, nothing. 4 and 8, yes. 4 will go into 4 once, 4 will go into 8 2 times. So now let's multiply. We've got 1 times 2, which is 2, 1 times 11, which is 11. What she's going to do is take 2/11ths home. And if you think about it, if I've got 8 parts out of 11 left of the cake, or there's 8 bits of cake out of the 11 left and I quarter them, of course I'm going to take 2 parts out of the 11 home. That makes perfect sense. All right, so once you've completed that set work, make sure you go ahead and try those enrichment problems.